Now let's take a look at 3.4, measuring the Egyptian way. So we're looking at lengths of rope that is created from tying knots. So this is what your rope would look like. If you want to go ahead and create a rope, you can. You don't have to. You're going to have to imagine how it worked back when the Egyptians did it. But that's what they did. They basically took a rope and in equal intervals, it doesn't matter the length, as long as those intervals are equal, they tied a knot in that rope. So our story for today comes from ancient Egypt, and every year the Nile overflowed. It flooded surrounding lands and often removed markers for property boundaries. As a result, the Egyptians had to remeasure the land every single year. The plots were rectangular, so they devised a clever method involving rope with equally spaced knots that formed 12 intervals to help them create perfect right triangle. So they needed the right triangle because for every rectangle, it has 4 right angles. So they needed to make sure when they're creating these plots that those angles form a right angle so that their plot is perfectly rectangular. That's what they would use these ropes for. So here's the method if you want to do that, like I said. Otherwise, you'll just have to imagine what it looked like when the ancient Egyptians knotted their ropes. And we're going to be studying that idea of the side lengths of these ropes, of the right triangles. Again, doesn't matter the units. It could be in feet, inches. They probably didn't even have units of measurement back then. But we're going to be taking a look at the Pythagorean theorem, the a squared plus b squared equals c squared again, and answering some of these questions. So question number 1 is, if you have a triangle whose lengths a, b, and c satisfy that relationship, is it always and forever a right triangle? We're going to be looking at that question. And then suppose the side lengths of a triangle do not satisfy this relationship. Does that mean there's no possible way that it can be a right triangle? So we're going to try to answer that question as well. You have a couple of lab sheets that go with these questions. Let's take a look at those lab sheets. Here's your first lab sheet right here that goes with that table in your book that you're asked to fill out. Now, the first question says, copy the table below, which we have here on our lab sheet. Each row gives 3 side lengths. So here are your side lengths. So you have a row here, side lengths, side lengths, side lengths. Those are all the side lengths of a triangle. Using string, straws, or poly strips to build triangles with the given side lengths, complete the second and third columns of the table. So you can use pieces of spaghetti. That's probably the easiest one. So you would have, you could have smaller pieces of spaghetti. So let's say each one is about 1 inch in length. You could have 3 of those for one base, 4 for another base, and then 5 for the hypotenuse. Remember, the hypotenuse is always the longest side, so that's how I know that 5 has to be the hypotenuse, and see if that works. So do that for each of these. Okay, and if you don't have pieces of spaghetti, or they say to use poly strips, that's fine. You can use even a couple different rulers and measure out. So a 3-inch side, 4-inch side, 5-inch side, and see if you can't get them to make a right triangle. But somehow try to answer the 2 questions. Do the side lengths satisfy the a squared plus b squared equals c squared? And is it a right triangle or not? So let's take a look at the first one, 3, 4, 5. If you measure something out, so it's 3 by 4, and then you try to put this hypotenuse right there, that is a right triangle. So yes, this satisfies. All right, and if you go through this next one also, but then the 5, 6, 10, that does not. So that will not work. The 6, 8, 10, that one does. This one does not, and this one does not. So if it satisfied this, then it has to be a right triangle. So the first 2 would be yes. And if it doesn't, there's no way that it can be a right triangle. So those all would be no, and this one would be yes because it satisfies the a squared plus b squared equals c squared. And then on part B, number 1, it says make a conjecture about triangles with side lengths that satisfy the a squared plus b squared. That's all of this. So make a conjecture. If it satisfies this, I would say my conjecture is, hey, listen, if it satisfies this, then yes, it's a right triangle. It has to be a right triangle because look at that. All of those that did, they created right triangles or they formed right triangles. So that's number 1 on part B. Number 2, go ahead and try 2 and 3 on your own. 2 is make a conjecture about triangles with side lengths that do not satisfy. So what about those other ones? And then 3, check your conjecture with 2 other triangles. So those 2 other triangles, try to find one triangle that would satisfy a squared plus b squared equals c squared, and then find one that would not on part 3. All right, so my conjecture for number 2 about triangles with side lengths that do not satisfy this, that's those 3, they do not form right triangles. It's impossible to create a right triangle because if you had, let's say you had a side length of 3, 4, and then 8, that third one would be way too long to fit in there, so it's not going to work. Okay, so it has to be 3, 4, and 5 in order for that to work and not be too long because that angle has to be a perfect right angle. So on number 3, conjecture with 2 other triangles. I can come up with 2 for you if you weren't able to do this. Let's do one of the triangles to have side lengths 9, 12, and 15. Okay, and we're seeing if it fits that conjecture, so we can draw it out, that's fine, but we know that 9 squared plus 12 squared, and those have to be my legs because they're the 2 shorter sides, and the hypotenuse has to be 15, so 9 squared plus 12 squared equals 15 squared. We're going to try to figure out if that makes a true statement or not. Go ahead and do that if you haven't done that. And then our other one is going to be 2, 7, 10. Okay, so then it's going to be 2 squared plus 7 squared equals 10 squared. See if that makes a true statement or not, and then come back to the video. On the first one, 9 squared, that's 81. Plus 144 equals 225 because 15 squared is 225. And if you add those together, they do equal 225. So this is yes. And if you draw that out, it will form a right triangle. Let's take a look at the next one. That gives you 4 plus 49 equals 100. These do not add together to give you 100, and so no, that is not a right triangle because it does not satisfy that equation, a squared plus b squared equals c squared. Now let's take a look at part C. It says determine whether a triangle with the given side lengths is a right triangle. So 1, 2, and 3 straight up give you side lengths, and you have to plug those into the a squared plus b squared equals c squared. Remember, if it satisfies that equation, then it absolutely is a right triangle. And then 4, Diego says he knew that one of the above triangles would be a right triangle. It is a scale copy. Now remember, we talked about scales quite a long time ago, last year. So what does it mean if something is a scale copy of another triangle? And then do you agree with his thinking or not? And then 5, Reka claims that if the lengths of the 3 sides of a triangle satisfy the relationship a squared plus b, then it has to be a right triangle. We've already said that. Okay, so she reasons as follows. Take 2 shorter side lengths a and b, use these to form a right angle, then a right triangle. Call the length of the hypotenuse D. Since the triangle is a right triangle, then a squared plus b squared equals d squared. You also know a squared plus b squared equals c squared, therefore c squared equals d squared, or c equals d. Since three sides of one triangle are the same as the three sides of another triangle, then these two triangles are the same. This means that the original triangle is unique. So, question down here, does Reka's reasoning prove the conjecture if a squared plus b squared equals c squared, then triangle side lengths a, b, and c is a right triangle? You might have to read through some of her statements right here, but go ahead and try 1 through 5 in part C. Pause the video, try those, and then come back and see how you did. Okay, in the first one, you would have 12 squared, let's do this again. 12 squared plus 16 squared equals 20 squared. Well, if you work those out, yes, it does satisfy the equation. If you add 12 squared and 16 squared, it is equal to 400. And then on number 2, 8 squared plus 15 squared, does that equal 17 squared? And that also is yes, therefore it forms a right triangle. So 1 and 2 form a right triangle. But then here you have 12 squared plus 9 squared equals 16 squared. This one, 12 squared plus 9 squared, is not equal to 16 squared. So in that case, it does not form a right triangle. So in your notes, please don't put just yes or no. Please write out what I'm writing here so that you can go back and use these to study. Number 4, Diego says he knew that one of the above triangles would be a right triangle is a scale copy of the right triangles in question A. So in question A, if you think about here, like right here, this one, we're focusing on this one because this was our first one. Okay, so that is a right triangle, and he's saying that it's a multiple of that. So if you look, our first one was 3, 4, 5, 3 by 4 by 5. You can see that that is a multiple, 3, 4, 5. So times all of them by 4, times 4, times 4, times 4. 3 times 4 is 12, 4 times 4 is 16, 20 times 4 is, 5 times 4 is 20. So I have those times 4s on the wrong side, but you get the idea, right? So it is 4 times the size, but it's still a right triangle. And in fact, this triangle right here, the 3, 4, 5, that is the smallest triangle with whole number sides. Right, so if I asked you if 30 by 40 by 50, if that would make a right triangle, what you would do is see, hey, 30, 40, and 50, are those multiples of 3, 4, 5? Meaning, am I taking 3, 4, 5 times the same value to get 30, 40, 50? Yes, it's times 10. So it's a scale model of the triangle 3, 4, 5. So sides 30, 40, 50, yes, it would be a right triangle. That's number 4. Pause the video and answer that question as needed. And then number 5, with her claims, yes, everything she's saying is true. Essentially, you can create any two sides that create a right angle and then figure out what this length have to be, and you've got yourself a right triangle, and that's what she's saying. So on part D, it says the Egyptians' knotted rope has 12 segments. The rope could be used to make several triangles with whole number side lengths. Only one of the combinations of side lengths gives a right triangle. So on this one, what combination? So we've already talked about this option, but what combination of whole number side lengths makes a right triangle, and how do you know this is a right triangle? And then what combination of whole number side lengths make a non-right triangle? All right, so go ahead and answer 1 and 2, thinking again of that rope with the 12 knotted segments as you try to answer these. Pause the video and then come back. So number 1, if you have a rope and you're creating a right triangle, the only whole number triangle that you could make is one that has 3 knots this way. So 1, 2, 3. 4 knots this way. So 1, 2, 3, 4. And then 5 knots this way. So 1, 2, 3, 4, 5. And that would give you the 12 knots total. So 3 plus 4 plus 5, 12 knots total. Okay, that's the only triangle that you can make. And then what combination of whole number side lengths make a non-right triangle? Well, there's many, right, that would make a non-right triangle. Because if you had 5 and 5, that wouldn't even make a triangle, right? But it would make, let's say 2, 3, and 5, something like that. 2, 3, and 5, or 2, 3, and 6. Even all of those would be non-right triangle. The only whole number right triangle is a 3 by 4 by 5 triangle. And we know that it's not because when we add these, so let's say we had 2, 3, 6. 2 squared plus 3 squared does not equal 6 squared. And you can test that to make sure that it doesn't add up to 36. That means it's not a right triangle. That is it for measuring the Egyptian way using the knotted ropes, which is kind of cool to think of. Things that we do today seem so simple, but the primitive ways that they used to measure and get perfect right angles back then is pretty amazing.